Close this.
Yeah, good morning. Can you hear me fine on your side?
We can hear you. We're just trying to get your slides up.
Okay. So I started screen share. Let me know if I need to restart.
Yeah, yeah, oops, I can see it, but I can't. Let's see if I can get this to. There we go. So let me introduce you before we begin. You have to go back. You're one up, so maybe you go back to your intro.
Yeah, I did. I think there's a delay.
Oh, okay. Anyhow, I think we could possibly blame this meeting on Roger Brewer because Roger contacted us. Oh gosh, it must be about a year ago now, and we had a call with Roger and Harry Beller and some other folks and talked about the data that he'll start showing us today about how in Hawaii they were collecting data using the top assay and the standard methods and trying to understand what was going on with the PFAS that they were seeing at wastewater treatment plants and at some contaminated sites. And I think what really got us thinking was here is a real problem that regulators are trying to address of how to interpret these data and how to relate them to the need to protect public health in the absence of actual standards. And so I think it's a compelling story of how these methods are out there and they're starting to be used by people to understand the world. And we all have this shared goal of not playing the chemical by chemical game of addressing contaminants, but rather thinking about classes of chemicals and avoiding regrettable substitutions and these other problems of contaminants getting out there and creating problems after we think we've done all of our remediation. So with that, I'll turn it over to Roger and then we'll have a discussion. So start thinking about either the synthesis questions you want for all three talks or specific questions for each talk. And Roger, it's all you and we can hear you just fine.
Okay, can you see my first slide now?
Yes.
Yeah. Okay. Okay, let me know if it's not changing. So yeah, thanks for having me. Sorry I couldn't make it. We're pretty busy here in Hawaii. It's gonna be a busy summer. So today I want to give you an update on Hawaii's guidance. Here I have it in parentheses or in quotation marks for PFAS, because really by now we didn't start looking at PFAS until maybe 3 years ago. We heard about it in the news and on the side, but we finally started getting data for sites here. We reached out to pretty much anyone who knew how to spell PFAS. And I just use the term PFAS in the US. Also talking to people abroad, been working with researchers in Japan, quite a bit in China, and also more recently, this photo here you see in Australia, we started working with a big group there. It is quite an international issue. In Australia alone, the group there was made up of people from China, Bangladesh, India, the Philippines, Nigeria. So it's a global issue now. It's definitely not just in the Western countries. So today I'm going to give you a brief preview, or actually a post view, I guess, of a presentation I gave to state risk assessors back in April. That's posted to our YouTube webpage. It's about an hour long, so we go on quite a bit. So I'm just going to give you an overview today. These are our guidance, the interim soil and water action levels for PFAS, as we term it. You see the web page there. Also, a short, just one or two references on the TOPS analysis. We're all experts in that now after hearing the last two presentations. And then I particularly like Atea's 2023 paper, just mainly because it's easy to understand. It helped us understand what TOPS is in general. And then the So It All method is one of the better methods out there now for the TOPS method itself. One thing, we're working in China as the state regulator, which I am. I'm with the state government. So we have to make decisions on a day-to-day basis, based on the best information we have. So we can't just stop what we're doing and tell the property owner, whoever, we'll be back in 2 or 3 years after we do more research. So that's one thing one reason why we're looking at the TOPS analysis and other types of analysis I'll go over today. So after spending a year looking at this and looking at data from our sites and talking to other people, we realized we had 3 separate groups of PFAS that we need to look at. One is what I refer to as pre-TOPS PFAS. It's what's reported in standard laboratory methods. And then post-TOPS PFAS, after you oxidize the sample, a new suite of PFAS appears, the precursor compounds. And then a third group of PFAS, where we'll look at all three of these groups individually, where there's still a lot of excess fluorine in the water that's probably attributable to PFAS. It's not getting picked up in the TOPS analysis, in the list of compounds they test there, or in the pre-TOPS analysis. So we'll go through those one by one. That start off with, I looked at the toxicity factors for each of 23 different PFAS compounds that we compiled information for now, mostly the terminal endpoint compounds. This just demonstrates how you have the long chain compounds here shown in red are more toxic than the shorter chain compounds. This is all relative toxicity compared to the butanoate. So one thing we see popping up quite a bit now is the hexasulfonate in water samples, not just in Hawaii, but especially in the US and other places. And if it is as toxic as the octasulfonate, it's going to start driving risk probably more than PFOS or impacts to drinking water systems. The short chain compounds are a lot, they're less toxic, but I compared the toxicity to more common contaminants. So, less toxic doesn't mean non-toxic. Even PFBA, the butanoates, has about the same toxicity as hexavalent chromium, TCE, benzene. And then when you get in the middle part here, you have similar toxicity to DDT, TCE, arsenic, PCBs. So, lower toxicity doesn't mean non-toxic at all. These are still pretty toxic compounds. Not as toxic as dioxins, but the way things are heading seem to be going that way. These are based on ATSDR's toxicity factors for PFOA and PFOS. So this first group of compounds now, we have 18 terminal endpoint PFAS compounds, non-precursors with toxicity factors, physiochemical constants. So we can treat them like any other compound. And we can develop, risk-based action levels for EPAs, risk-based screening levels for soil and for tap water. We do something similar. We also look at leaching of contaminants and other topics, issues like vapor intrusion if needed. And as you can see here, the long chain compounds are highlighted in yellow. The numbers are lower than the numbers for the compounds in green. There's the short chain compounds. So it's just restating that the longer chain compounds tend to be a lot more toxic than the short chain compounds. We only have toxicity factors for one ultra short compound. That's the propanoate. And it's kind of in between. It's down with the short chain compounds in terms of toxicity, but still fairly toxic. You can see the tap water action level for the propanoate is still 510 nanograms per liter. So compare that to MCLs for something like benzene, which are 5 micrograms per liter. So we have these toxicity factors. You can see the MCLs put in there just for reference. Then we can treat them like we do anything else in a risk assessment. So a really basic risk assessment, you take the concentration reported in the sample, divide it by your action level or screening level, in this case for residential uses, and that gives you a hazard quotient. Here's some data for a wastewater treatment plant biosolids that we have. We've collected influent, effluent, and biosolids data at 9 wastewater treatment plants. So dividing the pre-TOPS PFAS by the action level, hazard quotient, add up your hazard quotients. As long as they're less than 1, 1 or less, let's say, then it's not really significant risk. We round off to the single digit. So if we only ran pre-TOPS analysis on this particular sample of biosolids, not a big deal. So in theory, the kids could play in these biosolids on a day-to-day basis, not have any health effects, at least from the PFAS compounds. So that's fairly simple. The problem is we have all these other precursor compounds that aren't taken into account there that they've already mentioned. A big one for AFFF is the 6,2-fluorotelomere thiamidosulfonate, which has been one of the main components of AFFF for the last 20 years. Any recent, in the last 20 years, release of AFFF you've had, this is going to be the main PFAS there. If you're only testing for the standard list of PFAS, you're totally missing it. Then, of course, there are PFAS associated with food wrappers and containers. These are the fluorotelomere alcohols. And especially when you start looking at the wastewater and biosolids, we've done quite a bit of sampling of now. And there's a lot of stuff in there. We'll look at that in a minute. So how do you deal with this? The TOPS analysis has been great for that, for us being able to see these compounds. I'm not going to go into detail how it works. You can see it here. I keep it simple in my workshops. I compare TOPS analysis to pruning a tree. Look down at the bottom, the precursors, these metabolites. Think of the functional groups of this stuff added to the main part of the PFAS compound is the leaves and the small branches and stuff. Well, prune the tree, that's really what TOPS does. what it does is it exposes the terminal endpoint compound that's on the trunk of the tree. So now we can see these compounds, we can do something with it. So an assumption we make up front, now that we can see these, is we'll assume that the mixture of these post-tops terminal endpoint compounds, the toxicity of the mixture is assumed to represent, in general, what the toxicity would be of the mixture of metabolite product compounds. This is an example of the first site where we ran TOPS on. It's the AFFF fresh release spill. And we had pre-TOPS data. We actually collected the samples ourselves. We always collect multi-increment samples here. Thanks for the point out, Jean, about avoiding grab samples. They really should be avoided for anything. Wastewater, definitely for soil. You miss a lot of stuff. But you see the pre-TOPS versus post-TOPS data here. In some cases, the pre-TOPS data were over 100 times higher than the post-TOPS data, over 100 times higher than pre-TOPS data. So we're missing 99% of what's in the soil if you're just looking at pre-TOPS data. This is a sample for wastewater treatment plants. We check the influent, the effluent, and biosolids. And you can see in the influent, we see a lot of these 5,3-fluorotelomere carboxylate, which no toxicity factors for. The lab may or may not be reporting it. So if you could easily be missing these compounds, even if we catch them, no toxicity factors. We don't see those in the effluent from domestic. These are mostly domestic wastewater treatment plants. It looks like it's getting pretty effectively oxidized into the pentanoate or other terminal endpoint compounds. But look at the biosolids. They're just packed full of these metabolites and other compounds, no toxicity factors for. You see a lot of the 5,3-fluorotelomere carboxylate again. So first, there's a lot of compounds getting reported. If we bother to that extent, we don't have toxicity factors for. And then run TOPS on it, and the concentrations are typically double, triple, or in one case up to even an order of magnitude. And these are domestic wastewater treatment plants. So that's another big problem. A lot of compounds out there, we detect them, no toxicity factors, and we're missing most of what's there anyway. How do we address this? Well, we have pre-TOPS concentrations for these samples. We have post-TOPS concentration. So subtract pre-TOPS from post-TOPS. This gives us the concentration of post-TOPS PFAS, as we call it. And you can see here that the main makeup of these post-TOPS PFAS for the biosolids. We see this routinely now with these shorter chain carboxylates, as I think David and Jean both pointed out. So now we have a second list, a second group of PFAS that we can also assess risk by comparison to our action levels. Here's how we do that. Here's the same sample, just looking at the post-TOPS PFAS concentrations. These are all the terminal endpoint compounds that were generated by TOPS, in addition to the ones that are already there. Compare that to our soil action levels, soil screening levels. One by one gives us a hazard quotient. Add them up, that gives us a hazard index. Now, the hazard index after post-TOPS here, now it's 4. Before it was just 1. So the toxicity of this mixture is actually, when you add those together, it's 5 times higher than we originally thought. So if you're only testing for pre-TOPS compounds and biosolids, you're way underestimating the risk, as well as the total mass of PFAS in the sample. So this is helping put us in the right ballpark. There's a third group of compounds. We thought we were finished, and I talked to Wendy Link, I think, who's in the audience with you there now. And she pointed out that in some of the water samples they're seeing a lot of excess fluorine. So if you have the post-TOPS data, which actually we don't really see a big change between pre-TOPS, post-TOPS water samples. But if you look at your post-TOPS samples, the data, you have a list of compounds, the concentrations. You can predict what your total organic fluorine concentration would be based on the chemical formula for those compounds and the concentration reported. Then compare that to the concentration of absorbable organic fluorine for liquids, extractable organic fluorine for solids, your total organic fluorine. And your total organic fluorine tends to be much higher, especially in water samples, than what you would predict. So this is what these excess fluorine PFAS, what we refer to. So we run non-targeted analysis on these samples we have, and pretty routinely it shows a lot of ultra-short compounds in the sample that weren't being reported under the post-TOPS or even the pre-TOPS analysis. So things like propanoate, and I've heard also now more recently the trifluoroacetate. And then if you look at the breakdown of some of the compounds in TOPS and even in nature, then you can get carbon-carbon breakage of the PFAS compounds. So there's a lot of these fragments out there. maybe 1 or 2 carbons with fluorine attached that are floating around in the groundwater. I refer to these as PFAS debris these days. Quite a bit out there, though. So how do we deal with this excess fluorine? Well, we only have a toxicity factor for the propanoates. So just to get us in the right ballpark, what we do is we take the total excess fluorine in the water samples or in the soil, it's mostly water, and then convert this to an equivalent concentration of propanoate. Again, we're essentially converting the excess fluorine into total concentration of ultra short compounds with the propanoate as a surrogate. And this is pretty simple to do. It's basic stoichiometry. You take the excess total organic fluorine concentration, multiply it by the propanoate molecular weight, and divide that by the atomic mass of fluorine times the number of fluorines in the sample, times 5. The shortcut is take your excess fluorine concentration, multiply by 1.75. So we're estimated equivalent concentration of propanoate. We have toxicity factors for the propanoates. We can calculate soil action levels, drinking water action levels. We can do the same thing for food. Now we can use that to calculate a hazard quotient. Here's an example of some excess fluorine at AFFF site, a fire training area. This particular one's on Maui. And once we start looking at the excess fluorine in the water, there's a lot in there. It makes up a large proportion, at least a third to over half of the total PFAS in the groundwater itself. So just looking at the proportion of these compounds make up in water samples, at least here in groundwater samples, it's important to look at them. When we look at risk, though, this is for total concentrations. Here we're looking at the total risk, relative risk. It's really the pre-tops compounds, the PFOAs and the PFOSs that are driving risk. The excess fluorine is a lot there, but because the toxicity is so much lower than PFOA and PFOS, it doesn't tend to drive risk. So it may not be that necessarily a big deal in terms of risk that we're missing it, at least for this particular site. The post-tops, we run tops on our water samples. We don't see a big change most of the time, but of course, like the way science is, if you collect enough samples, you're going to start seeing what are mistakenly often called outliers. It's probably real data, but for some reason, one of the samples, when we oxidized it, the concentration of PFOA, I think it was actually PFOS, just shot up in the sample. I'm not sure why. But that's a quick look at the total organic fluorine, how to deal with it. So we have 3 groups now, the pre-tops PFAS, post-tops PFAS, and our excess fluorine PFAS. I think we're getting in the right ballpark now and being able to assess risk, making calls on a day-to-day basis on how to deal with these sites. And what we did in our office, we made this simple for consultants to use. We put it all in a spreadsheet. So on the right is our total PFAS risk calculator. And someone told me a long time ago, it's only useful if it'll fit on one page. It's pretty much what this does. So you put in some basic side information. This is for a wastewater treatment plant. Select whether it's a liquid or a solid. That changes the units in which action levels is compared to. And you select land use, it's residential land use, commercial, industrial land use. And that's all you do on this page. The second worksheet, you input your total organic fluorine data if you have it. We didn't in this particular example. And you input your pre-tops data, input your post-tops data. And other worksheets will calculate a post-tops concentration of PFAS, and they calculate a hazard quotient for pre-tops and post-tops hazard index. And then they do the same thing. The other worksheets will calculate a total excess fluorine and compare that to action levels for the propanoate and calculate a hazard quotient. Then you go back to the first page. On the bottom right in blue, if you can see the 2-point font, it'll calculate a total hazard index for that particular sample. So it's pretty quick and easy. It gets us, I think, in the right ballpark. Here's some examples. We were wondering, can you drink the water out of a wastewater treatment effluent plant with respect to PFAS? We wouldn't do that anyway, although a lot of it is crystal clear, I have to say. This is 7 wastewater treatment plants, effluent. So these, we had pre-tops, post-tops. Actually, here we didn't have tops on 4 of the samples. We did have tops data on 3 of them. It didn't really make a big difference, we saw. But the hazard index, like how toxic are these PFAS and wastewater treatment plant effluent, this is mostly domestic plants. The hazard index is below 1 for 4 of the 7. It's not that high, not that far above 1 for the other 3. Once the hazard index gets above 3, risk assessors will start squirming a bit. 3 and below, not that big of a deal. So this was interesting, at least in the wastewater effluent we're seeing, PFAS aren't that big of a deal in terms of health risk. This is an example of wastewater treatment plant biosolids. So can you take these biosolids and spread them out in a playground and let kids play in them? When the one treatment plant we looked at, the hazard index came out to be 1. So yeah, it's fine to do that in terms of PFAS. The other 3 wastewater treatment plants we have data for. I've actually got data for 3 more. I haven't had time to put it in here. Hazard index, when you look at post-TOPS data, jumps up to 5. What's driving risk? It's not the PFOA and the PFOS here. There's not that much in the solids. It's mostly the short chain compounds and the precursors that will be driving risk, and we looking at those after TOPS. So that's a very quick overview of the approach we've been using. Again, talking with quite a few people. There's actually ever groups in the U.S. doing this, mostly for food. Same thing in China. We met a group there. They've been using TOPS analysis there, and even in Australia, they're also using it, especially for food. We use it especially for water. I mean, for solids and for biosolids and compost and things. Some of the pros of this approach, it allows consideration of precursor compounds instead of just ignoring them. When you ignore them, as a lot of states are doing now, you're essentially saying they have a toxicity of 0, which we don't recommend doing. We did put together a pretty easy to use spreadsheet. We have our password in there. People can change it as needed if they come up with a better way to do it. Cancer risk, mostly focused on a few well-studied PFAS. Yeah, very similar to the way we look at petroleum contamination. TPH is the mixture. Assess the toxicity with respect to it, and then assess toxicity of individual compounds, BTEX and pHs. Some of the limitations, the TOPS method is still evolving, and it's, they don't directly mimic biological processes. We know that, but it seems to be producing the same suite of compounds that we see in some of the studies of natural oxidation of PFAS that we've looked at. So I'll end with that. We have time for questions. Some of the research we're doing now, we're looking at leaching of PFAS from biosolids. So that's a big issue where they spread biosolids on fields, working with the laboratory in Canada on that. Bioavailability of PFAS in soil and biosolids. We're actually working with the group in Australia on this. We've worked with them before. It's Albert Juhas, Ravi Naidu these days. We looked at bioaccessibility and bioavailability of arsenic. Now we're just switching over to PFAS. Uptake of PFAS in the food crops, that's a huge deal. We started working with some groups in the U.S. mainly, but especially some large-scale studies going on in China right now. I'll be over there this fall working with them. So I'll end with these 2 quotes from Mr. Box and Mr. Keynes. All models are wrong, but some are useful. So, is TOPS perfect? And the TOF method we're talking about perfect? No, but they're definitely useful. And then with Mr. Keynes, it's better to be roughly right than precisely wrong. Any questions? To be happy to chat about. And again, thanks all for the input we've gotten for a lot of people in the group on our guidance.
Thank you, Roger. So Jean, come on up. Roger, we're imagining you sitting here with us, but we could hear you. So maybe folks in the audience could come up with some questions for us. I can facilitate the questions and we can have a discussion for the next 20 minutes or so. Or if you have nothing to say, it's still get coffee early.
One thing I'd point out, the report that we're still getting our TOPS data, the labs are pretty overwhelmed. Our PFAS data, we're still waiting for the last data for our study. Hopefully I'll have a draft report posted. I say by the end of the month, they're probably early June.